Hi everyone, my name is Anton, and today on my channel I have an interesting guest. Andrei, R&D team lead at Verigram. Verigram is a face recognition company ranked top 10 on NIST. Also, Andrei is known as chief organizer of ODS CV in industry conference. Also, he have a lot of interesting lectures and videos, and he is one of organizer of the online data breakfast. And you can go on online data breakfast every Wednesday, 10 a.m. Moscow time. So let's start and speak about modern face recognition. Here is Andrei. Welcome.
Yeah. Glad to be here.
Okay, let's start from my first question. Your company has been doing face recognition for a long time, and it's clear that during this time the company usually solve different problems. So let's, for example, speak about just last 6 months. What percentage of the R&D team time is spent on dataset work, testing new architecture, working with new hypotheses? Maybe I forgot some
Right.
big problem.
That's a big question. So let's talk about that from that perspective. We are not a big company. We have less than 30 members, and our R&D team is quite small. We have only 3 or 4 active R&D engineers who are doing all research and integrating into production environment. It's like most of the time we're doing some tests regarding the needs we need to address right now. So it's not like we're spending all our time on research that will be like published 6 months into the future or anything like that. It's not like academic research. So we're actually most of the time we don't have huge resources. We have small servers that we can compute our neural networks. But so that's kind of pressing, right? We don't have luxury to like spend on one task all of the time, and especially like most R&D guys actually now, and most of the time that I was working with Verigram, they were on OCR team. Like they were doing our very doc product that is trying to understand what is showing to the camera on ID cards and something like that. Yeah, on the face team, it's even like 2 guys, me included. So we're not like spending time doing like hyperparameter research, etc. We're mostly doing data research. So we're trying to analyze what kind of problems we have with our data, where we can find new data, which partner we can ask for more details about our products, what doesn't work for them, what works for them. For example, this summer there were debates with some of our clients or maybe future clients about our face work, that it's working too well in low light conditions. Like it's a problem for some customers because they want to approve, they want like human approval process additional to neural network process, so that the neural network works well is kind of a problem for them. Yeah, and there was also like contributions based on different things. So yeah, Basically, we're mostly doing work on our data and with our partners to understand what works well and what not.
Okay, and if we focus on the time a bit earlier when you create a new algorithm, during this creation, how much time do you spend on architecture, how much on data collection, or it's
Right,
usually
it's
around the same?
right. It's quite difficult question for because it depends on the task. For a lot of tasks, we have some kind of approximation, like first network, some kind of maybe research that we redone from papers, etc., etc., like retrained networks from dataset that we can acquire from our partners or from different methods. So basically, first proof of concept is like done in 2 weeks, maybe in a month, and after that, it's just kept improving with a lot of new data, with different techniques, maybe. So first, it's also like I can't say that we don't do like neural architecture search, like hyperparameter optimization. We do all these things, but like the process is the continuation of everything around data. So you just pass the data, you try to analyze it, maybe some techniques like GradCam, like you try to analyze which part of your data is not suitable for your task, or maybe like it's too difficult for neural network to learn the data, so we try to make it easier. Like for first iterations, it's usually for first iterations and proof of work, it's necessary to have really clean data and rather easy to learn for neural network. So after that, you can like make huge nets learned on huge, maybe noisy data, and that's another like problem.
Okay, and let's dive a little deeper. Uh, of course, everything is important for the top place on NIST, but when you try to maximize quality and minimize the cost, how important are architecture? Because a lot of people think that architecture is the holy grail and you need excellent architecture. Uh, let's speak a
Right. Yes. That's something is coming from like junior engineers and from the academia, I suppose, because I myself was thinking something like that. I was trying to come up with a great mathematic like interpretation of this architecture and show that it should be working due to math, not due to some metrics, etc., etc. But like in reality, everything is matter that your client is your clients like you, your methods work, and they're used under different constraints. So yes, so that's why I was talking that it's not all about neural architecture, like maybe neural architecture search, etc., etc. It's more about the data. So like linear data, easier the process. Like most likely better algorithms. It's come like the simplest things works all the time. Like either you're doing tables, like other domains or computer vision. It's the same everywhere.
Okay, and for example, do anyone use transformers for face recognition nowadays, or usually try to use more simpler nets?
Yeah, you can see last publications from Inside Face group that they were using VAT transformer. So yeah, it is usable thing. I
But
can't say that it's better or the best thing, but well, you can use them. We are actually using some transformers for our different things, but it's like not like the Holy Grail or everything needs to be a transformer. No, it's just everything we can reach at, everything we can like try to do, we're trying to do in our little like constraints that we have. So like we are trying to come up with idea and to fail it fast. So if you have an idea that the new architecture should work, you should first fine tune this architecture to like your data, see if it's better than I either fine tuned net that we had. If it's better, then we can train it on more data and see if it's work. So like yes, the first thing that you should test your hypothesis faster, because most of the hypotheses don't work. So you want to know it faster than like you spend a month doing your training from scratch, and after that you find out that it's not better.
Okay, and speaking of architecture, I always interested about do we have nowadays some end-to-end face recognition because
Like detection integrated
yeah,
in
yes, yes,
recognition.
yes, or do someone
I
use such
haven't
approaches?
seen this approach done. It can be done because you can like just apply recognition to detection phase and do it
Like
end to
something
end.
like retina face, I don't know, when you try to put
Right,
a
right, yeah, yes, you can do this, but your network becomes really huge. And as we know, detectors don't filter all those proposals. They try to come up with all the proposals they can. So your inference time will suffer, first of all. And second, is that we have already quite huge model zoo pre-trained networks that do specific tasks, and it's just easier to use them than to come up with a huge new architecture, try to make it work.
Yes, yes, and I think it's pretty hard to balance such data set on training phase because it's you need to like some triplet loss or so. Speaking about losses, which losses are modern and everyone start to use them?
Margin-based loss,
Okay.
like arc phase, fear phase, you name it.
Yes, because myself I working with face recognition pretty a lot a long ago, but so usually we use summary identification losses for different tasks, and I'm not even sure what is modern and pretty cool. Okay, let's speak about datasets. As you
Mhm.
mentioned, datasets it's more important than some
Yeah,
architecture. And how big modern data set for training good recognition neural
like a
network?
modern dataset,
In
tens
huge
of
product.
millions of images. All
Okay.
right, so yeah, around that.
Okay. And how do you collect them nowadays? Because, for example, 7 years ago, it was everyone tried to scrub the internet and find every data set that they meet. But I assume that nowadays you can use even some generation neural network for dataset creation.
Right,
How is
yes.
modern pipeline looks?
Like I was a skeptic that generated faces could work. I'm still kind of skeptic about this because I haven't tried it myself for like production thing. But the latest research from Microsoft team shows that it works. At least for them, it works. Right. So generally, you can use that, but I think that it's still easier to scrap internet. It's because to render a face, you need GPUs that you can't spare and everything else. So right, yeah, it's just easier and like cheaper to scrap the internet for everything you can acquire, to ask your consumers whether they can provide you data, because when you're first starting like a new face project, not only face recognition, you don't have a lot of data, like you can scrap internet for it. But your clients can provide it. They can provide some insight what they want. So first datasets are mostly like combination of some kind of you could scrap, and what your like consumers provided to you. And as a bonus, you can fine tune your dataset for your consumer and provide a better algorithm for them.
Okay, and probably some technique about some deep image augmentation, like rotating face, will work, or how deep usually people go there. Because I know that for some human body identification, a lot of work start using such neural network that will rotate a person in different position, and they start using this almost 2 years ago. So I assume that probably such technique will be helpful in face recognition, but I've never seen anything like this.
Right, yeah. I've never seen it accomplish something like good. And I think it's because in full body identifications and full body recognition tasks, you have really much variety on your images that you can see. And with faces, it's most likely an unfast face. And maybe some rotations, etc., etc., and you can see almost everything that you can see like in 2D. You don't need to rotate it or anything else. Maybe you can add like glasses, masks, masks. Augmentations were popular 2 years ago. There were actually a huge competition around that. So yeah, they are working. You can actually add some face scars, etc., etc. But well, everything these hard. It is hard to do it on the fly, like when you're trying to learn and do augmentation. So you either need to sample some data sets and augment them and store, or you need huge servers to do it on the fly, which, well, we can't afford it. So we tried some different things like that. They were working for different tasks. So yeah, you can do this, but not like rotation faces, etc. Yes.
Okay. And speaking about data generation, let's speak from different side. A lot of people try nowadays trick such system by some gun generated faces, like to registrate on some site with wrong ID card or something like this. How good such approaches nowadays? Will they work someday? Will they win someday? Because I think that face generation quality increasing each day. So is it possible way to fight such problems? Or
well, first of all, they are working like in the field. There are a lot of research around that deep like how it's like deep fakes are good at fooling people. There are different approaches to try to battle it with simple things like rotate your face, and because for now at least, generated images don't work on profile faces. Well, and they do a lot of artifacts like with overlays on, etc., etc. But when we're speaking about real like customers that want to optimize the registration process, they won't integrate such thing in the process because it's too difficult for consumer to follow all those instructions. So what they want is not that bulletproof protection from generated faces, but they want some compromise between your approach to bottle it and easiness of instruction that a person can follow. It is a problem for different things, but for mobile, like you can't, at least for now, you can't generate faces in real time using mobile phone, even if you have a rooted mobile phone. So, right, but if you don't have your communication secured, like you don't know from which source your video is coming, you can't really say for sure if it's generated or if it's stolen video from someone, because like phishing attacks is a thing. You can steal someone's data, someone's images, someone's videos. You can actually just download videos from a person's Instagram and try to show that video. Yeah, so the problem is about controlling your environment and controlling the video feed from the camera to your service. Right. Yes.
If this pipeline isn't controlled, you can trick a system even nowadays with 100%.
Yeah, if a person controlling this environment and controlling the video feed, it can rather easily fool the systems that like with a fake person. It's actually done in the wild.
Okay, and speaking about some different problems and neural networks around face recognition, how much usually you need different neural network to complete the face recognition task? I think usually for different tasks we use like quality estimation neural network. Sometimes we need some neural network to estimate that image shoot from right position, for example. And how much usually this stuff will work around the main face recognition neural network?
Right. For most of projects I know, it's just two networks, maybe three. One is detection and one is recognition that produce your embeddings. Maybe there is a third network that's doing a quality check, but it's not like must-have feature.
But how then you can estimate the probability that face is correct? Because when you try to compare two blurred faces, of course they will look the same. Or how do you fight this problem when the images with poor quality can look the same?
Right. Yes. Usually it's not our case. Like we don't have a lot of things that have such a pure video quality. Mostly you have really bad quality images from low light, and if they're taken from really far away. And really far away is not our case, actually, for our products, for at least right now. So we don't spend a lot of time on that thing. Low light quality is like learned on the fly, so it's bottled this way. On like blurred faces, mostly it's like low resolution video or low like face captured from really far away. Like you have surveillance camera and you're trying to recognize from these positions. that is mostly not our case. So we are not battling it, for example, for at least right now.
Okay. And because when you sometimes for some project I take in some open source neural network and they become pretty unstable. For example, when they meet highly rotated face or some incorrect camera position, and usually we append like this checking that face is pretty big and from its orientation is like the person looking in the camera. But
Right. For now, what I mean by face detection, most face detection networks now have integrated landmark detection. Like retina face have 5 faces. We in our pipelines have also a network that can detect all 68 landmarks, like standard in the DLEAP and OpenCV landmarks. So you can try to acquire information through that. You can just using all those landmarks, you can acquire information about rotation, about what's like your camera position, etc., etc. So that quality you can do without networks.
Mm-hmm. Okay, and let's speak a little bit more about the product itself, like the main face recognition idea. And nowadays, there are a lot of people realized that face biometric is their property, and I think that it will completely change the landscape of face recognition because people understand that their face can work against them. And how do you meet with this problem?
Right.
What it will change in your pipelines, ideas, and in your product?
Right. The most important thing for consumers is that we don't collect the data without their permission. So we're not storing everything we our service captured. And the main thing I think is not like consumers are not they don't know enough about like how the face can work against them. Because you can see that everyone is online, everyone is posting faces everywhere. So you are not like it's not about you like you're posting your face. It's about where your face is stored. Like you are feeling safe when you're uploading to Instagram, to Google, to Facebook, etc., etc. Like they won't like steal your data, but other providers can. So whether this like safety is guaranteed is up to debate, but like I would like consumers to know more about this, data safety and how can they approach this more. So it's not like anything will change in our pipeline because our pipeline is stateless and don't store itself information. So it's like if consumer wants the data shown, like for court cases, they need video feeds, faces, etc., etc. So we provide them this data and don't store it on our servers for like our needs if we don't have a contract with our client that we can use them. And yes, most clients don't like to use the data.
So you're thinking that the future of this problem is about not storing and probably even not streaming personal data outside the device. if it will be possible, because I even know that there are some cameras, they provide not video stream but like skeleton stream or stream about.
Right. Yes, there are cameras that have all the pipelines on themselves. Like they do everything and they can provide only embeddings. Yes, I think that the future, if we want safer like future for our personal things, is about doing everything on device as much as we can, and provide only some hashed data to servers to like we can well, we can divide our networks, like have detection is not a really hard task if you're working with mobile phones and selfie images, and you can do it on device easily. And you also can like slice your recognition network and do first convolutions on device and only send to the server the feature maps from several layers. And you can show consumer that we're doing as much as we can to provide security, to not store your faces as it is, but to like, and even we are not even like using your camera as a streaming device. We're only passing ourselves data because your device is not strong enough to do all the work. So yes, I think the future is like doing most things on device.
Yes, but of course, first layer, the neural network after first layer, usually it's pretty. The features are pretty good to restore the face if you doesn't use some tricks
Yes,
to
you're right about that.
prevent this.
Yes,
Yes.
yes, we can.
Uh,
We could do
okay.
this.
Okay, and speaking from the different side is when we looking at the NIST, we can see 400 different companies there, and I think that not every face recognition company present on NIST. And the one question that's been interested to me is there room for everyone? Because I think that company fight each other, and how do you think it will look in few years? Will they merge and we will
Oh, I
need
think
like
it will be just more companies on NIST list. I mean, it's not about that that your company being on the NIST list is a necessity for everyone. It's mostly necessity for when you're working with rather huge clients or clients that are like knowable about the field, that you can't just come up and show like we have a great algorithm that's tested. Most like I was hired because of such request actually, because the network that was Telegram at the time was not good enough for NIST. Well, at least as they thought it. And several clients wanted like company to be on the NIST list and to be rather high. So yes, first my first task as an employee in the Telegram was to somehow give this approach to become like recognizable provider, at least in Kazakhstan. And we accomplished that being the first from Kazakhstan, and actually I think it's the first from Central Asia company being on the NIST list. And we're still, I think, the highest from like Central Asia.
so. And when we're speaking about the face recognition, we can either mention that there are a lot of different biometrics, like I don't know, fingertips biometrics,
Iris,
iris
yes.
recognition, and some other. How? What do you think? Will it for like for last 5 years? Usually we didn't hear about a big progress in these fields. And what do you think? Will the progress will return to some of these biometrics? And
Well, actually, for fingertips, the progress is done. I think it's after the huge success with on face biometrics, like face biometrics everywhere, and fingertips are not used for some reason. And the progress was done there. You can actually see NIST also doing different team, but also under NIST doing research in fingertips. And they shown that there is a huge progress in this field. Yes, for iris they don't do it, so we are not sure actually how either other biometrics are working. But I think that it's everything comes down to how easily you can capture these biometrics using consumer devices, because most of the time it's about consumer registering somewhere. It's about KYC. It's about something like this. So it's about how easy you can use consumer device to capture your biometrics. For example, you can't use fingertips because not all mobile devices have fingertips recognition, and you are trying to work with like photo captured fingertips, and it's a mess because for one, it's all conditions should be quite good to capture it right, and other things that actually well, it's even harder to battle anti-spoofing for fingers that for face. So yes, I think that the problem is about capturing those biometrics on devices.
Mm. And when we speak about iris recognition, because we were working a lot with iris recognition before neural network era, and that time it was even some missed competition around iris recognition. I'm not sure
Yeah,
that it's still working, but yeah.
Well, it's not ongoing competition, so yes.
Yes,
It's
but
not
probably
updated.
if the quality of the camera will increase, even face recognition you can use somehow iris information, because iris have a lot information. I assume that two iris have even more information than one face nowadays. But what do you think about this? Did you saw some project
Yes,
probably?
about uh, like our faces are different. Like the genetics are different. There are actually some research that's trying to show that even like same like if the people are alike, that the genetics are really alike. So yeah, I don't think that iris is like have better information. It's more about how you can recognize that information from your captured image, because for iris recognition you need a special device with a special light that will capture everything rather clear, and your your iris will be centered, etc., etc. We don't have that luxury with faces. If we'll have a special device that will center face with a great lighting, etc., etc., it should work as good as iris recognition for that. But like as I said earlier, it's mostly about doing everything using consumer devices. So I don't think it will like work better.
Okay, and let's speak about face recognition from a bit different perspective, not the product, not the algorithms, but more about infrastructure. How important is infrastructure, like training infrastructure, data storing infrastructure for such problem, and how do you usually work with this?
Right, infrastructure is everything. If you don't have an infrastructure, you lose a lot of time. Like, you need infrastructure to store, not only store your dataset, but store every different version of your dataset, because you add data, you subtract data, you modify your data, maybe you try to do everything, and you need to store it and know which model on which dataset was learned for your validations. So yes, you also need infrastructure for automatic validation. Best to have it. Um, yes, and well, at least some infrastructure for experiment uh, for experimentation, for your colleagues to know what you're doing and which experiment is now running, etc., etc. Like experiment tracking is like great thing. So yes, everything about DVC, other things to store that information is yes, is a necessity. I think.
And which data lake do you use? DVC or some other?
We're using, yes, we're for different projects we use different things because it's like kind of a mess every time we're trying to stabilize on something. We're using combination mostly DVC on S3, S3, our local S3, not on Amazon, and stored archives with hashes. Like because if you have a huge data set, tens of millions of images, DVC is really slow to get a hash from it. So we have custom custom wrapper around for calculating and checking hashes for different things. Like yes, and all those huge data sets are stored and like tar archives that each have each own hash, and we can combine these archives however we like.
So you don't use like tech cloud for each images. You use like tech cloud for some batch of images.
Right, yes, because if you're working with a lot of data, it's not necessary to shuffle everything like perfectly, because you don't need it for your learning procedure, because neural network will forget everything about these first images when they try to learn on tens of millions of images. For like randomness, you can skip some images, like you only store a whole batch, but you sample from it like every second image or every third image. And then you shuffle in memory some of your batches to have some randomness. And you don't need to shuffle all the dataset.
Okay, and what infrastructure do you use to proceed experiments? Do you use like some probably ClearML or some
Yeah,
Airflow
we're
build?
using ClearML.
Ah, okay, okay. It's became pretty popular nowadays. And you use do
Not as
you use
popular as MLflow.
yes, but do you use ClearML even for experiment tracking because it have some internal system for like comparing
We are
different.
using mostly for experiment tracking. Yes. Also, there are some like things integrated in ClearML that I will want to try my hand on for even better infrastructure for experimental scheduling, and because it have different queues on different workers, etc., etc. But like everything, building infrastructure takes time, and like with a small team, we don't have a lot of free time to spare. So yes.
And when you're training on such big data sets, how do you How big do you cluster of GPUs to train your neural network? Do you try to train it on one GPU or is it some bigger?
Mostly, like most of our projects are not using really huge data sets, but and they're working on one single GPU at a time. But for phrase, I was actually using HiveMind to make a cluster from different GPUs and workstations, and have like four GPUs, different architectures on different workstations to work on experiment.
Okay, it's very interesting. And I think that I'm out of question. Thank you, Andrei, for such interesting discussion, and thank you for your time.
Yeah, thank you for having me.